course, part of it relies with him. So I'll quickly get started. I think I have a lot of slides to cover. So why do we need syntax highlighting? Ever since I started programming, I think my first programming was in BASIC. It was all black and white. There was no color. But then the CRT monitors, monochromatic monitors changed to color monitors, and code editors always did this syntax highlighting of programming languages like C. So all programming languages have a set of reserved keywords, which usually gets highlighted when you open them in a code editor or sometimes even a text editor. And this is usually nowadays enabled default. Sometimes it helps with readability. For example, if I quickly want to look at the begin and ending of the abstract, that's really highlighted here in the editor of my choice, Vim. That's a LaTeX document that's highlighted. And you can see that even certain control sequences are colored differently, such as the author title are colored differently from the address, make title, etc. And CVR and I had a discussion when we saw the prior art that Heikki did, and he immediately came up with a requirement that we have a lot of wiki articles to help the LaTeX authors as well as copy editors and operators. So there's a lot of inline and block display code of LaTeX, which currently is highlighted using some heavy plugins. So if we could have a font with the TeX syntax highlighting baked in, might be a good idea. Some people call it a crazy idea. Let's see. The state of the art is that many desktop applications have their own syntax highlighting method, like a theme file, etc. Some of them I'm familiar with. Emacs has a language mode, which enables this syntax coloring. And Vim has their own format of the syntax coloring, which gets loaded on demand based on the file type. And KDE applications, they share a particular theme file. And in web, there are JavaScript frameworks which does syntax highlighting of many languages like Prism, Highlight.js, etc. And MediaWiki, which is what we use for our internal documentation, has a few plugins, and the installation instructions by MediaWiki itself says that these could be really heavy, so that it slows down the page loading. And when it comes to TeX and LaTeX, there are a couple of packages which are generally used by authors, such as minted and listings. Minted in particular could be problematic in some situations because it requires shell escaping, so the code goes out of TeX compiler, goes into the operating system, and comes back. So it might be a security risk in many production systems. What we could do instead is, why not embed colors in the font itself? So color fonts has been a thing for so long, but it's used for very special purposes, such as Photoshop or InDesign could make use of this for some designs. But there's a long history of it. So around 2010, there were multiple competing color specifications added to OpenType. OpenType is a standard maintained nowadays by Microsoft, but it's actually joined a project by Adobe, Microsoft, and possibly Google nowadays. And it's an extensible format. It's very packed and compact format, but it could be extended without breaking backward compatibility. So if you add a new feature to an OpenType font and it's not supported by the application, it'll still continue to work the way it used to before. So for example, if you add color to the font and your application doesn't support it, it would still work as, say, black and white or monochromatic. And why around 2010? Because that's when everybody and their pets had a smartphone. And what is smartphone good for? While sending colorful emojis across the globe. So that was a big requirement, and everybody developed their own standard. Apple had something called SPIX. Google had something called CBLC and CBDT format. Adobe and Mozilla were betting on OpenType SVG, and Microsoft was backing a standard called CPAL, which is color palette and color format. All of this format, except of course the SVG, was a raster. So they embed rasterized PNGs, for instance, to have a bit of shade or a bit of depth. But when you zoom it up, you can really see the artifacts. OT-SVG was really vector-based, but it has it required a lot of heavy processing because of the possibilities SVG specification offers. And that's how it looked like, say, around 2010. And you can clearly see here the artifacts. It's something like a painting I make. And what happens when we have a number of competing standards? Well, this is where I insert this famous comic from XKCD about standards. You get to have another standard. And if you think this is a joke, well, it really happened. So in 2019, Google actually tried to improve the CPAL color format, which was the format backed by Microsoft, incorporating some advantages of OpenType SVG so that you can have vector layers instead of rasterized images in there, and then transformations like scaling and rotating without losing any clarity, color gradients, shading, etc., etc. This is now known as COLRv1. So the earlier CPAL color format is known as COLRv0. Fortunately, it got caught on, and it's supported by most major operating systems, desktop applications, especially web browsers, with one notable exception, which you can imagine, is Safari and Mac. So as of this writing, I think version 26 in beta still doesn't support the COLRv1. And that's the outcome. So you can see it has nice shade, depth. So it looks like a painting made by Rubens in comparison. So now we know, yes, we can put color into font, into glyphs particularly, but how do we get syntax highlighting? Because you can color all glyphs or some glyphs in particular color, but how do you get that intelligence into it? That's enabled by OpenType programmability. OpenType gives us also programmability into fonts. Fonts nowadays are really dynamic software. It's no longer static software from 1980s. There's some person who implemented a complete LLM, aka large language models, or aka ChatGPT stuff, into a font. And if you use that font and you type in a word, it's going to auto-complete the sentence for you. So there are a lot of stuff like this. The OpenType programming is limited. It's even Turing complete, although really hard to work with. And the key features are known as feature and lookup. These are the technical terminology used by OpenType. And in particular, the one useful for us is glyph substitution. Technically, it's known as gsub. That's glyph substitution, where you can replace a sequence of glyphs with another glyph, or one glyph with a number of glyphs, but not a number of glyphs with another number of glyphs. So there are certain limitations, but there are certain possibilities as well. For instance, if I have an OpenType lookup rule like this, which says that substitute glyph F, glyph F, glyph I by a single glyph F underscore F underscore I, that's how you get this beautiful ligature, FFI, if that is supported, if that glyph is present in the font, with the same glyph name. It's optional, particularly for nice to have for Latin scripts, but it's absolutely mandatory for complex scripts like Indian scripts. to get the proper conjunct formation. So we have vowels combining with consonants in a series of layers. And here I'm telling, this is taken from the font Rachana, which has extensive character set of Malayalam. So here I am telling, replace that 8 characters with a single character, and the result looks like this. So that's really 8 Unicode code points. That's the longest conjunct in Malayalam, to my knowledge. Now, this still wouldn't help us with syntax highlighting because it requires certain knowledge of the context. So OpenType has something called contextual alternate or CALT, where you can replace glyphs only in particular context. So if it is preceded by certain characters and followed by a certain characters, only then you can replace it. So here if I want to replace only the glyphs C and D marked by this prime symbol, only if it is preceded by the characters glyphs A and B and the glyph E with F, I can have that. It's really possible. This would be very helpful in implementing the syntax highlighting. So technically, or in syntactical analysis, the preceding characters are known as backtrack, and the following characters are known as look ahead. You can have any number of glyphs following this or preceding this. I don't think there are limitations. One thing to notice here is these names, they are not characters or Unicode code point, they are just glyph names which are in the font. And these rules are written in Adobe feature file format, which makes programming OpenType fonts much simpler compared to what you could do in font software such as font making software such as Glyphs app or FontForge, etc. Now, how do we get to implement it? Well, first thing is there's a wonderfully written article by Heikki Lutvonen last year or so. If anybody who's interested in how this all works, he has a very detailed write-up, a deep dive. I encourage you to check it out. There was a lot of discussions in typo.social, which is a Mastodon server for many of the type people hang around, and Hacker News, etc. So what do you need to cook this up? You need a few ingredients. First of all, you need a base font. Plus, each glyph which requires a different color need to be duplicated. Fortunately, you don't have to redraw the whole glyphs again. OpenType has this feature of references to base glyph, so that cuts down the file size by a lot. And then you need a source file format. What Lutvonen did, he did it all in Glyphs app. I don't use Glyphs. I prefer to use open source tools and softwares. And there is a tool called FontMake, which is maintained by Google. It can do a lot of stuff. It can generate color fonts, it can generate variable fonts, and a lot of things. So FontMake can take in either glyphs or something called UFO. It's not the one that you're thinking about, the flying saucer, but it's the unified font object. It's a text-based font format, so that's very easy to transmit or do version management. The next thing is that you need to define a color palette. That's the cpal, and everything in OpenType is implemented as binary tables. And each of these table has a particular name, code. So color palette is called cpal. And then once you define the color palette, say 5 or 6 colors, you can assign one of these colors to a particular glyph, or maybe a blending, but I'm just going to go with a single color. That makes the implementation simpler. And then, of course, you need an OpenType feature file which actually writes the rules, how the syntax highlighting should or could happen. Once we have all these ingredients, you could simply run FontMake, and it will build the binary font either in OTF or TTF format. And from the OTF format, it's fairly straightforward to generate web font format using the font tools. So how do we do it? First of all, like I mentioned, we have the base character set here, up till here. So I took the wonderful M+ code Latin font by Koji Morishida. It's open licensed under OFL, Open Font License, so which allows modification. And then you get to duplicate all these characters or glyphs which are going to have different colors. Again, you don't need to completely duplicate it. You can have a reference to it. And the way it is named is the capital letter A is going to be named as uppercase A itself. But the next one is going to be named as A.alt1. This is A.alt2 and A.alt3. That's the glyph name. You could name it a different way, but it makes easier for me to program it because I know what it means. And FontForge, that's shown in FontForge. If it is in glyphs, you could actually see that these glyphs are actually in different color. And FontForge can actually generate UFO format, straightforward, specifically UFO3, which keeps everything in a ordered directory fashion. So if you named your font whatever name, it'll have a directory called that font name.ufo, under which we have the features which you need to supply, or it'll generate one, but it's going to be useless for our use case, which holds the OpenType rules. And the metadata about the font, such as the family name, ascent, descent, style, license, copyright, and all sort of stuff. And the next important thing is a property list, lib.plist, which holds the color palette and colors. And the individual glyphs are going to be under this directory. This is created using DAR tree, and it's formatted very nicely thanks to a piece of code from Eric Ninehouse. All right. So the next thing is we need a color palette. You can have n number of palettes, more than one, in a single font, but I went with a single palette because that makes my life easier. And for each, this is where the syntax sort of highlighting coming in. So I've designed 6 or 7 colors. Color 0, we programmers like to start indexing from 0. It's for control sequences. The control sequence in TeX, for those who are not familiar with, which are a few in the audience, is a backslash, or technically an escape character followed by a word. So I'd color it in a red, brown, or something. And optional arguments and comments, I would color it in gray. Ideally, these could be separated, but being the lazy person I am, I decided to go with a single color. And then environments are going to be colored in, say, steel blue. Numbers in, I don't know what that color is. Is it light purple or something? And math switch, such as dollar, subscript, superscript, the caret symbol, underscore, @, macro parameter, they are colored differently. Delimiters and binary operators, they are colored in orange. And this is how you can define the color palette in that lib.property list. It's an XML file, and you absolutely must have the key com.github.google i18.ufo2ft.colorpalettes. This is the Python library that does the heavy lifting of everything, right? And then how do you define the color palettes? Well, this is one color palette in this array where you can define several colors like I did. So if that's red, brown, it's a real value, so it's a floating point value, 4 values. You would imagine this would be RGBA, alpha channel, but no, it's BGRA. I have no idea why OpenType has that specification, and I think UFO to FT actually requires it in RGBA, so it does the conversion automatically. Standards. Now, how do we assign a color to each glyph? That's the color, COLR table, and that needs to be defined in this fashion. That's the UFO to FT.color layers, and I'm going to color all the letters in 3 different colors, one for control sequence, one for comments, and one for the environment names. So I need to have 3 different colors. So I will assign each alt1 this index, which is here, right here. the palette index. All the other stuff are the complication that you get from the color layers, the OT, SVG, COLRv1 layers. How to paint these colors, how to paint these glyph, etc., etc. This is complicated stuff. I'm not going to go into details. And then, of course, you will have the next one, Alt2, with the next palette index, index 1. And that's how it might look like. So I'm going to color numbers only in one color, backslash, which is the escape character in TeX, in one particular color. Dollar I need for math, and then in comments I need to be gray, so on and so forth. Now the juicy part. So how do we actually implement the OpenType rules? You can define glyph classes, so you don't have to list every glyph, and it even takes ranges. So A to Z uppercase and A to Z lowercase. If your alternative glyphs follow the same similar naming convention, then that makes it easier. But you can do this for numbers, because numbers are 0, 1, 2, 3, etc. And we are going to use our venerable friend cult contextual alternative feature with a lookup for the TeX control sequences. And I've got two rules in here. So as I mentioned earlier, the glyphs marked with the prime will be replaced. Without, they are the context, they remain. So I'm going to substitute anything that is preceded by the TeX escape character, which is nothing but backslash, followed by a letter, any letter here, by its alternative form. That's rule number 1. So what it gives me is that if there is a backslash and a letter, it's going to be replaced with its alternative 1 form, which is the red-brown color. And then I have a second rule where, well, I get /t in /TeX colored in red-brown, but not the EX. So how do I get that? What I do is that I look if there is an alternative colored glyph behind me, and then I can color this letter. It is strictly a letter with the same color. That's how the state machine is implemented. So if there is an alt1 glyph behind me and I am a letter, then I replace it with its alternative color. So that kind of a recursive programming, and that's it. That's basically it. And this is how it works. So if you have an input /tex, backslash is always already colored with the red-brown color, and then you have TEX to process. Well, this is really ideally step 0, but in step 1, so I'm going to focus on T. So the shaping engine actually runs through each rule successively. So it first tries to match this. Do I have an escape preceding me? Yes, if I am T, I have an escape behind me. Then I'm going to replace this T with T.alt1. That's rule number 1. All right. And then the next letter is E. So it's going to run through the same rules again. Is E preceded by an escape? No. So rule 1 won't be applied. But is E preceded by an alt letter 1? Yes. So the rule 2 is going to apply, and it's going to replace E with E.alt1. That's rule 2. Similarly, the next letter. And then you have control sequences. So control sequences always contain only letters. If there is a white space or a number or anything else, these rules will not be applied. And then anything following will not be colored. How do we build the binary font once we have all these ingredients? That's fairly easy. I have a make file with these targets, OTF and WOF. So if I run make OTF, it runs font make on my sources, the UFO file with the OTF format, and that does all this compilation. And finally, it generates the OTF file. Very unintuitively named font, better name is welcome. And then the next target is make WOF, which generates the web font, which you can embed in websites and web pages. using the font tools. So we get the WOF2. And thou art promised colors, and I deliver the colored font. So that's really just the font without any JavaScript or CSS or any other libraries. It's just the font doing the colors of a TeX document. So I've even implemented the optional the description of theorem with the different color. So is with the cite command. You can have a preceding and following the part of the citation. And dollar is the math switch is colored differently, but it's going to follow the comment which is colored in gray over here. So it won't be colored separately. And that's basically it. How long do I have? Another 10 minutes? Yeah, okay. Then I'll quickly run through. So this was our requirement, basic requirement in a wiki page. That's the wiki source code. So if you use the pre-formatting code, that is enclosed in no wiki tags, and inline we'll be using code, and that will be colored as we wanted. The color scheme is not static, at least not in browsers, because color fonts are much better supported in browsers, and you can override these colors using CSS, the font palette values, and override colors. So you could, remember I had 6 colors? You can replace them with whatever color you want to, and that's what you get. Comes to application support, most of the web browsers, of course, except Safari, supports this very well. The free type rasterizer, which is the underlying technology for most of the free software platforms, and I think even Apple uses free type, has support for color fonts since version 2.11. The UI toolkit's Qt since 6.9, I know. GTK4 since I don't know which version, at least for a couple of years, they do have the support. A lot of proprietary DTP applications do support them. Have you a question, Boris? All right, okay. When it comes to TeX, CTeX do not support color fonts. Lua TeX with half bus render does support COLRv0. There is no COLRv1 support to my knowledge. When I tested, we tested Lua TeX development branch, and I don't think it supports it yet, but it does support COLRv0. So I also generated COLRv0 font from the same sources, but the lib.plist, the property list, is completely different. So I need to have a different version for it. But I dynamically switched during the building, so I can build the COLRv0 and v1 dynamically on the fly. But I found a small bug. You remember the previous slide where the Pythagoras theorem was actually completely colored in gray? And the comments, I don't think it works as expected. So I looked into the documentation Khalid Hosni had written, the Tugboat article initially. And it looks like what Lua TeX does is that it passes the token list to the half bus code word by word, because words are usually separated by a white space. A white space is just a white space for browsers and applications, but not for us TeX. It's a glue. So that gets replaced with a kern node, I believe. So I think that might be the case why on white space it breaks, but it still doesn't explain why it breaks on the quotation mark, because it's a single run, or at least it's supposed to be. So I'm not sure it's worth reporting upstream. If it is, maybe I will. So you could do this by setting them, you need font spec, of course, render half bus. It doesn't work otherwise, because all this heavy lifting is done by the half bus shaping engine. It has a lot of limitations because it's done within a week, because I was hard pressed to implement it before the talk, and I had to write the presentation and the article. And and it does the job for our requirement, but it's extensible. Particularly OpenType shaping, it shapes line by line, if I'm not mistaken. So you cannot continue the previous color onto the next line. So that breaks coloring. And the white space, so if you have a begin theorem, it's perfectly legal to write /begin, space, curly brace, open, theorem. But that white space, OTL doesn't have a really regular expression format where you can say 0 or more instances of this glyph. That's really not possible. You have to list them out, everything. So there is no elegant solution. And if you have 3 spaces, that's already blows up in exponential matter. So that's not really nice. And LaTeX 3 macro names, as you have seen yesterday, can have underscore and colon in them. But underscore, we already have a color for math subscript, so you can probably blame Frank for it. And then Lua, HP, TeX, and Safari, they support COLRv0, not COLRv1. A few possibilities. Yes, some white space could be handled by just duplicating the OpenType rules, but I'm just a bit lazy to do that. And there was a suggestion in Typosocial, I think, or Hacker News. Yeah, Typosocial. Behdad was suggesting that instead of contextual alternate, maybe Harfbus has a WebAssembly feature now, which is giving a lot of power to the font, even more than what OpenType gives. You could do a lot of things. For example, Arabic typesetting. OpenType still fully doesn't support Arabic. It's not perfect or precise. But the WebAssembly, there is somebody who implemented an Arabic font in Harfbus Wasm, and it works wonderfully well. And the LLM feature that I mentioned earlier is implemented using WebAssembly. And of course, it could be extended with more color palettes, etc., etc. And the entire source code is publicly available under Open Font license in GitLab under the RIT fonts. It's not any resemblance of RIT with Rochester Institute is purely coincidental. It's Rajana Institute of Typography. It's a volunteer collective, including CVR, me, and Narayana Patadri, who did all these wonderful calligraphy posters, and Hussain. Of course, without Heikki Lotmonen's prior art, we wouldn't even be attempting it, and I would then definitely be able to complete it within a week. The wonderful M+ code Latin font by Kochi Murshida, which is what I used for all these monospace font. We like it because it's compact, quite legible. Rahul Krishnan, who did here a lot of testing and gave us a lot of feedback about the color schemes and its readability, etc., etc. And of course, Carlbury for all the discussions and feedback, even though this is syntax highlighting is one sure way to annoy him because he doesn't like it at all. So, yeah, but he was kind enough to agree to publish this article in TechBot. If you have any feedback, you're welcome to write it to my email ID, rajesh@rajana.org.in, or I'm on Typosocial, but not on anything that owned by the multi-billionaires in Silicon Valley. All right. Do I have enough time or no?
Thank you, Rajesh, for the talk. Now we can take questions.
Boris wants to go first.
Yeah.
It's from me, it's not from online, I don't see online. When you go to L3, it's not just underscore. They have this pesky colon and arguments, and you probably want to have different coloring for the main command and for the signature. So you probably need, I wonder whether it's even possible to do with OpenType programming.
I don't think it's possible because assume you have /beta_2 or n+1. And this I cannot distinguish from LaTeX 3 control sequence. This is really dumb syntax highlighting. There is no intelligence whatsoever. It's not even LLM. So Frank?
Yes, but I'm still not quite sure whether you have context. You should be able to know whether you are in math context or not. Why can't you carry that on?
If the entire math is on a single line, it may be possible.
Okay, so it's because of the line-based restrictions.
Yep, because of the
okay,
line
yeah,
break.
that
The macros are always, you better write them in separate lines.
okay. But just to Boris, I don't think an Expl3 programmer would want to have the signature of a command being highlighted differently from the command. That's just annoying. I would go with COLRv in that case. I would like to see the command, and I'm able to see where the colon is in the command. So.
I had a backup slide. I don't think I will have time, which is why I put it as a backup slide. This is how the environments are colored, and you can already see how complicated this could be. Any other questions? If not, thank you very much.